Assalamu alaikum, dear students. Welcome to DigiHub Learning, where we make computer education simple, interesting, and easy to understand. Today, we are going to learn about the generations of computers and discover how computers changed throughout the history of technology. The development of computers is divided into 5 generations, and each generation introduced important improvements in computer technology. From huge machines using vacuum tubes to intelligent computers powered by artificial intelligence, this is the amazing journey of computer evolution. Before studying each generation, we must first understand what the term generation of computers actually means. The word generation refers to a particular stage of development in computer technology, marked by important technological improvements. Whenever a major new technology changed the way computers were designed and operated, it marked the beginning of a new generation. Each new generation improved upon the previous one, making computers generally smaller, faster, more reliable, and more powerful. Computer history is commonly divided into 5 generations, and each generation is associated with a different major technology. The first generation used vacuum tubes, which were later replaced by transistors in the second generation of computers. Later, integrated circuits, microprocessors, and artificial intelligence continued this remarkable journey of computer development. So, in simple words, a computer generation is a period of computer history defined by the major technology used to build computers. The first generation of computers existed approximately from 1940 to 1956, during the early development of electronic computing. The main electronic technology of this generation was the vacuum tube, which controlled and amplified electrical signals inside the computer. First-generation computers were extremely large, and some of them occupied entire rooms filled with thousands of electronic components. Because these computers contained many vacuum tubes, they required enormous amounts of electrical power to operate. The large number of vacuum tubes also produced tremendous heat, so special cooling systems were needed to protect the machines. Compared with modern computers, these machines were much slower, more difficult to operate, and extremely expensive to build and maintain. Programming these computers was difficult because instructions had to be written directly in machine language using binary digits, zeros, and ones. Another major problem was that vacuum tubes frequently failed, requiring technicians to replace damaged components and repair the computer. Important examples of this generation include ENIAC, UNIVAC, and EDSAC, which helped establish the foundation of modern electronic computing. So the first generation brought electronic computing to life, but its enormous size, high cost, heat, and limited reliability created serious challenges. After the first generation, computer technology made an important breakthrough, leading to the development of the second generation of computers. The second generation of computers developed approximately from 1956 to 1963, introducing a major improvement in electronic technology. The most important invention of this generation was the transistor, which replaced the large and inefficient vacuum tubes used previously. Because transistors were much smaller than vacuum tubes, second-generation computers became significantly smaller and required less physical space. Transistors also consumed much less electricity and produced less heat, making these computers more efficient and easier to operate. Compared with first-generation computers, transistor-based machines were faster, more reliable, and more efficient in performing calculations and processing information. During this generation, higher-level programming languages such as Fortran and COBOL became popular, making programming easier for humans. As computers became more reliable and practical, organizations began using them more widely for business, science, government, and large-scale data processing. Famous examples of second-generation computers include the IBM 1401 and CDC 1604, which were important transistor-based computer systems. In summary, transistors made computers smaller, faster, more reliable, and more efficient, marking a major step forward in computer technology. After transistors improved computer technology, another major invention led to the development of the third generation of computers. The third generation of computers developed approximately from 1964 to 1971, bringing important improvements in computer technology. The most important technology of this generation was the integrated circuit, commonly known as an IC or simply a computer chip. An integrated circuit allowed many electronic components, including transistors, to be placed together on a single small chip. Because many components could fit onto one chip, computers became significantly smaller while becoming faster, more powerful, and more reliable. During this generation, operating systems became more advanced, allowing computers to manage programs and perform multiple tasks more efficiently. Computers also became easier for people to use, and their applications expanded into business, education, science, and many other fields. One famous example of a third-generation computer is the IBM System/360, which was designed to support many different computing tasks. In summary, integrated circuits made computers smaller, faster, more reliable, and more powerful, creating the foundation for modern computer development. The development of microprocessor technology brought another revolutionary change, leading computers into the fourth generation. The fourth generation began around 1971 and continues to influence the modern computers and digital devices we use today. A microprocessor is a powerful electronic chip that contains the central processing unit, or CPU, of a computer. Instead of requiring many separate electronic components, the microprocessor placed the essential processing functions onto a single small chip. The microprocessor made computers much smaller and more affordable, allowing personal computers to enter homes, schools, offices, and businesses. As microprocessor technology continued to improve, computers became portable, leading to the development of laptops, tablets, and other compact devices. Fourth-generation computers provided much higher processing speed, greater storage capacity, improved reliability, and powerful performance. Because of these improvements, computers became an essential part of education, healthcare, banking, business, communication, and everyday life. Today, desktops, laptops, tablets, and smartphones all demonstrate how microprocessor technology transformed computing for people around the world. In summary, the microprocessor made computers smaller, faster, affordable, portable, and powerful, beginning the era of modern personal computing. As microprocessors continued to become more powerful, computer technology entered a new stage known as the fifth generation of computers. The fifth generation is generally associated with the period from the 1980s to the present, with a strong focus on artificial intelligence and intelligent computing. Artificial intelligence, or AI, is the ability of computer systems to perform tasks that normally require human intelligence. AI systems can analyze large amounts of data, recognize patterns, learn from information, and improve their performance. Fifth-generation computers are designed to understand natural language, recognize speech, process images, and interact with people more naturally. Artificial intelligence is also closely connected with robotics, where machines are designed to sense their environment, process information, and perform intelligent actions. Today, AI is used in education, healthcare, transportation, business, scientific research, communication, and many other areas of modern life. The goal of fifth-generation computing is to create systems that can assist humans by understanding information, solving problems, and making intelligent decisions. In summary, the fifth generation focuses on artificial intelligence, intelligent machines, natural language, learning systems, and advanced human-computer interaction. We have now explored all 5 generations of computers, so let us compare them and review the major technological changes from the first generation to the fifth generation. The first generation used vacuum tubes, and its computers were extremely large, expensive, power-hungry, and produced a great deal of heat. The second generation replaced vacuum tubes with transistors, making computers smaller, faster, more reliable, and more efficient. The third generation introduced integrated circuits, which placed many electronic components onto small chips and made computers even more powerful. The fourth generation introduced microprocessors, placing the central processing unit on a single chip and making personal computers possible. The fifth generation focuses on artificial intelligence, allowing computers to learn, understand information, solve problems, and interact more intelligently with humans. The major technological progression was vacuum tubes, transistors, integrated circuits, microprocessors, and finally, artificial intelligence. As computer generations progressed, computers generally became smaller, faster, more reliable, more affordable, and more powerful. To remember the 5 generations easily, remember this sequence: vacuum tubes, transistors, integrated circuits, microprocessors, and artificial intelligence. From room-sized machines using vacuum tubes to intelligent systems powered by artificial intelligence, the history of computers shows an extraordinary journey of technological progress. And if you want to learn more about computers and technology in a simple and interesting way, subscribe to DigiHub Learning. If you enjoyed this educational video, please like it. See you in our next exciting educational video. Allah Hafiz.